Okay guys, let's wrap up rational expressions. We can do number 4. Here's an example where it might be advantageous for us to use our factor by grouping skills in order to clean these up in both the numerator and the denominator. ZW plus 4Z, they share a Z, times W plus 4. Negative 3W minus 12, share a negative 3, times W plus 4. In the denominator, the factor by grouping, they share a Z, W plus 4. They share a plus 5, W plus 4. So my factored form of this is we've got W plus 4 times Z minus 3 over W plus 4 times Z plus 5. Now you'll see the W plus 4's cancel, and we're left with Z minus 3 over Z plus 5. Okay, so one thing to note about this, for some reason many students will try to take these two Z's and cancel them out. You can't take Z's and cancel them out when they're added or subtracted to something else. Let's look at something like 4 plus 2 over 4 minus 1. We know that 4 plus 2 over 4 minus 1, this is really 6 over 3, which is 2. If you cancel these 4's out, you would get 2 over negative 1, which is negative 2. So this you can't do. The same thing goes for variables. You cannot cancel out one of a variable if it's added or subtracted to something else. Z minus 3 and Z plus 5, you can't cancel out the Z's and end up with negative 3 over 5. So it's really important that you leave these variables alone when they are added or subtracted to something. Now we'll also look at number 5. Q squared minus 4Q over 4Q minus Q squared. This is one of the special occurrences, but we can factor just to make sure. This is Q times Q minus 4 over Q times 4 minus Q. Now we know that Q over Q can cancel. Now Q minus 4, 4 minus Q, those are our opposites that go to negative 1. Let's see why this happens. I'm going to factor out a negative 1 from the numerator. All that does is change the signs. So that's negative Q plus 4 over 4 minus Q. Now negative Q plus 4, I can rewrite it with the positive term first as 4 minus Q over 4 minus Q. Now notice these are the same and they now cancel, and the only thing I'm left with is negative 1 over 1, which is negative 1. This is why if you see opposites like this, where one thing and the other are the exact same in the reverse order, they will always reduce to negative 1. Now, that doesn't mean the same thing as number 6. An opposite sign in the middle of the term doesn't let you cancel, again, because these x's are attached to numbers in front of them. 5 minus x and 5 plus x aren't the same as 5 minus x and x minus 5. So this can't be simplified in any way, so don't get the two rules confused. Okay, let's do some word problems you might see. Right, negative x plus 4 over x minus 3 in 4 equivalent ways. I don't really like this problem, but okay, we've got negative the original way, negative x plus 4 over x minus 3, where it's out front. That negative can be distributed to the numerator to where it's negative x minus 4, gets distributed to both terms, over x minus 3. That's the same. It can get distributed to the denominator to where this is x plus 4 over really negative x plus 3. You could write this as 3 minus x as well. Or you could both leave the negative out front and distribute it to both, because negative over negative is positive. So we've got negative x minus 4 over negative x plus 3. I think this problem, when you see it on the homework, is somewhat redundant and almost confusing, but it can be done. You could also technically write this middle one as x plus 4 over 3 minus x, and maybe that's a good fourth way. it's not my favorite kind of problem. I just want you to be aware that it is on there. Now the area of a rectangle is x to the fourth plus 10x squared plus 21. The width is x squared plus 3. Find the length. So we've got the width plus the length. We know the whole area is x to the fourth plus 10x squared plus 21. We know area is length times width. So it means x to the fourth plus 10x squared plus 21 equals our length times our width, which is x squared plus 3. To find the length, I'm going to have to divide by x squared plus 3. Okay, so we can either use long division, or we can kind of use a strategy here. I think they kind of want us to factor, so length is x to the fourth plus 10x squared plus 21 over x squared plus 3. Here's an idea. What do we know about x plus 3 times x plus 7? It's x squared plus 3x plus 7x plus 21. So it's x squared plus 10x plus 21. It's the same kind of thing here, only we have bigger values of x, and our denominator is a bigger value of x. So we can kind of use what I call a substitution. If we let u equal x squared, remember that means u squared is x to the fourth, because if you square x squared is x to the fourth, and I can use the substitution. Length equals u squared plus 10u plus 21 over u plus 3. And now I can factor the numerator just like I did over here. It would be u plus 7 times u plus 3 over u plus 3. This will allow my u plus 3's to cancel, leaving just u plus 7. Now I didn't start the problem with a u, so I can't finish it with a u. What was u originally? It was x squared. So this gives the idea that you can kind of factor the same way we normally factor, even when the variables are larger exponents than you've seen before. So our length here is x squared plus 7. And that is all for 6.1.